How are you, my friends? This is Calculus 1 solved questions. Find the inflection points, part 2. So please, you can go and check part 1. Question number 1, find the number of all inflection points of the function f of x is equal to sine of x in the interval 0 to 2 pi. To find the inflection points, we have to find the second derivative of the function. So let's start by finding the first derivative. F prime of x will be cosine of x. The second derivative will be minus sine of x. Let the second derivative be equal to 0. So minus sine of x is equal to 0. Sine of x is equal to 0. If you multiply with the minus, then x will be pi using this interval 0 to 2 pi. Now replace pi in the function. F of pi is equal to sine of pi, which is 0. Now we have to check the change in concavity. Minus sine of x, we check the sine of f prime, the second derivative. So pi here, before pi, we can take any number like pi over 2. So this will be negative. After pi, we take 3 pi over 2, it will be positive because this is minus sine of x. So here the function concaves down, the function concaves up. There is a change in concavity at this number. Then the function has only one inflection point, pi 0. Question number 2 is a nice question. If the function f of x is equal to x times e to the power minus x has an inflection point at AB, find the value of a over b. Same idea of question number 1. We will start by finding f prime. Here we can notice that this function has a product, x times e to the power minus x. So the derivative here we can use product rule, u prime v plus v prime u. The derivative of the x will be 1, e to the power minus x. The derivative of e to the power minus x will be minus e to the power minus x times the x. So take here e to the power minus x as a common factor. We have 1 minus x in the bracket. Now let's find the second derivative of the function. Also, we can use the product rule again. 1 minus x prime times e to the minus x plus the derivative of e to the minus x times 1 minus x. It will be minus 1 e to the minus x minus e to the minus x, 1 minus x. Rearrange all this second derivative, take outside e to the power minus x, we get minus 1, and x. So x minus 2 is there. Okay, so we know that e to the power minus x is always positive. That's an exponential function. We study f prime at 2. If we choose here a number 0, this will be minus. If we choose 5 or more, it will be positive. So we have also a change in concavity at 2. F double prime is negative. So the function here concaves down. F double prime is positive. The function concaves up. So one inflection point at 2. X is 2. Replace 2 in the function here. We get 2 e to the minus 2. This is the y value. This is a, this is b. So a over b, 2 over 2 times e to the power minus 2. Cancel the 2, move this one up. It will be a over b is equal to e squared. Question number 3, find all inflection points of this function, f of x, x to the power 5 minus 5x cubed. This is a polynomial function of degree 5. As usual, we find the second derivative. The first derivative here will be easy, 5x to the 4 minus 15x squared. Directly, we can find the second derivative, 20x cubed minus 30x. Let f double prime is equal to 0. I can take common factor here, 10x. Inside, it will be 2x squared minus 3. So I can factor more. 10x, this is the difference between two squares. Square root of 2x minus square root of 3. square root of 2x plus square root of 3. So x can be 0 or square root of 3 over 2. When you rationalize, you get square root of 6 over 2, or minus square root of 3 over square root of 2. When you rationalize, you get minus square root of 6 over 2. Now, this number here, square root of 6 over 2, is approximately minus 1.22, and this will be 1.22. Just make a table here for the second derivative. Remember, this is a table for the second derivative. We can see at this point, there's a change in concavity. At this point 0, we have also change in the concavity, and we have at this point. So the function has 3 inflection points. Take these x values, each one replace it in the original function, x to the power 5 minus 5x cubed. So the 3 inflection points, the points where concavity changes, will be 0, 0, minus square root of 6 over 2. You put this in the function, you get 21 square root of 6 over 8, and square root of 6 over 2, it will be minus 21 square root of 6 over 8. If you need where the function concaves down, this is minus infinity to this number, union 0 to square root of 6 over 2. Function concaves up on this, union this, if you need that in another question. Question number 4 says, find the product of the coordinates of the inflection point of the function f of x is equal to ln of x divided by x. Here we need to find the product of x and y if this point is an inflection point. So f of x is equal to ln of x divided by x. Let's find the first derivative. Here we see we can use quotient rule, u prime v minus v prime u divided by v squared. The derivative of ln of x, 1 over x times the x, minus the derivative of the x will be 1 times ln of x. This will be 1 minus ln of x divided by x squared. Let's find the second derivative. Again, we can use quotient rule. Minus 1 over x times x squared minus, in the formula, the derivative of x squared is 2x times 1 minus x squared, all divided by x to the power 4, which is the square of x squared. So this is minus x, and this is minus 2x, minus, and the minus becomes plus 2x, and then of x, we can add minus 3. And here we see there is an x common factor. It will be cancelled with one of the x's here. So we get minus 3 plus 2 ln of x divided by x cubed. Now this make the second derivative is equal to 0. F w prime is equal to 0. So minus 3 plus 2 ln of x is equal to 0. ln of x is equal to 3 over 2. So from logarithmic here, we can go to exponential. We say x equals the base e to the power 3 over 2. Now let's do table of sign for the second derivative to study that. So e to the power 3 over 2 is the value of the x, approximately 4.4. Coming from the second derivative is equal to 0. This is f w prime. So if we take a number less than 4, this will be negative. If we take a number greater than 4.4, it will be positive. So there is a change in concavity at this point. So one inflection point, this is the x value, e to the power 3 over 2. Replace that x value in the function here. It will be ln of e to the power 3 over 2 divided by e to the power 3 over 2. This you can bring it down. ln of e is 1, so it becomes 3 over 2 e to the power 3 over 2. These are the coordinates, x and y. This is the inflection point. So the product of the coordinates is x times the y. You can cancel this. The answer will be 3 over 2. And this is more information here. F concaves down on this interval. F concaves up on this interval. Remember here, ln of x, the domain will be starting from 0 to infinity. X should be greater than 0, not equal to 0. Question number 5, find all inflection points of this function f of x, x squared minus x in the bracket times e to the power minus x. Okay, let's find f prime using the product rule, u prime v plus v prime u. So f prime will be 2x minus 1 times e to the minus x plus the derivative of e to the minus x will be minus e to the minus x times x squared minus x. Simplify that, take x e to the power minus x as a common factor. Now let's find f double prime. Again, use the product rule. It will be minus 2x plus 3. You can see that so easy. So f double prime, after you simplify it, it will be x squared. You can check that, please. Minus 5x plus 4 times e to the minus x. We can factor this, x minus 4, x minus 1. And remember, exponential function is always positive. So when we make table of signs for f double prime, we put x minus 4, x minus 1. We take a number here less than 1, we take 0. Between 1 and 4, we take 2. Greater than 4, we can take 7. And then we have change in concavity at 1, change in concavity at 4. So 2 inflection points, 1 and 0, y 0. Take 1, replace it in the function here. And 4, replace it in the function e to the power minus 4. And here 4 squared 16 minus 4 is 12. So there are 2 inflection points. Question number 6, find the number of all inflection points of this function f of x, x square root of 6 minus x. Same idea, let's find the first derivative. Just a little note here, since we have 6 minus x under the square root, so 6 minus x should be greater than or equal to 0 to find the domain of the function. When you solve this simple linear inequality, it will be minus infinity to 6 closed. Now f prime will be also by the product rule. X times the derivative of the x is 1 square root of 6 minus x plus x times the derivative of this one here square root. It will be minus 1 over 2 square root of 6 minus x. Simplify that here, make the LCD 2 square root of 6 minus x. It will be 12 because this is a 2 and here we have 6 minus x. So 12 minus 2x minus 1 times the x here. So it will be 12 minus 3x divided by 2 square root of 6 minus x. I will make this one easy. I will just take 2 here outside times the same function here, 12 minus 3x over square root, because I need to find the second derivative. So I will not include the half in the derivative. It will be constant outside. You can see that there. Now find the derivative here. That's quotient here. See, this is division. So it will be u prime v minus v prime u divided by v squared. So minus 3 times this minus the derivative of this will be minus 1 over 2 square root of 6 minus x times 12 minus 3x divided by all this squared. Now here you have to be careful. In the numerator, we find the LCD. We multiply 2 square root of 6 minus x by this. Minus times minus becomes plus. And this will be the reciprocal, 1 over that. So it will be 6 minus x to the power 3 over 2. 3 over 2 is coming from power 1 here and power half. And there is a half here. 2 in the denominator. There is another 2 in the denominator. It will be 4. So please check the numbers. When you simplify everything, you will get 3x minus 24 over 4 times 6 minus x power 3 over 2. Take 3 as a common factor, x minus 8 over this. Now on the next slide, this is f double prime, 3 times x minus 8 over 4, 6 minus x to the power 3 over 2. This is the function given, and this is the domain of the function. F double prime is equal to 0, so the only value x equals 8. And we have noticed here the domain of the function starting from minus infinity until 6. 8 is outside. It is not even in the domain. So we cannot even study that. 8 is outside the domain of the function. And we can see here from minus infinity until 6, if you replace any value in the second derivative, it will be negative, so concaving down. So the function f concaves down from minus infinity to 6. And there is no inflection points. Why? Because there is no change in concavity. So to answer the question, find the number of inflection points. It is 0. For more questions on inflection points, you can see lecture number 19 in the Calculus 1 lectures. And for more questions on Calculus 1 in general, you can always visit the Calculus 1 solve questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.